Quadratic equations. So in the lecture series of quadratic equations in part 5 and part 6, we discussed about the changes in sign of the quadratic expressions with respect to the coefficients of x square and finding the maximum and minimum value of the quadratic expressions. Okay, so in that one we summarized the things what we learned. As the first thing we learned as, if the roots of ax square plus bx plus c equals to 0 are complex numbers, okay, then the expression ax square plus bx plus c and the coefficient of x square, that is a, have the same sign for all the values, real values of x. And the second thing we learned is, if the roots are equal, okay, if the roots are equal for the given quadratic equation, the roots are equal, then the expression ax square plus bx plus c and the coefficient of x square have the same sign, except at x is equals to minus b by 2a. And in that one we learned the third thing as, if the roots are real and distinct, okay, if the roots are real and distinct, let alpha and beta are the distinct values, and the condition it has to be satisfied as alpha less than beta, alpha less than beta. For the given quadratic equation, the roots are alpha and beta. Then, so in between, if the x lies, the values lies in between alpha and beta, okay, alpha less than the x less than beta, the expression ax square plus bx plus c and coefficient of x square have the opposite sign, okay, have the opposite sign. And for x less than alpha or for x greater than beta, the expression and the coefficient of x square have the same sign. Okay, in the next lecture we learned finding the maximum and minimum values of the given quadratic equation. So in that one, if the ax square plus bx plus c, if a is greater than 0, okay, if a is greater than 0, so if a is greater than 0, the function f of x will have the minimum value, okay, f of x will have the minimum value, and the minimum value at x is equals to minus b by 2a, and the minimum value is finded with the help of 4ac minus b square by 4a. And if the quotient of x square is less than 0, then f of x has the absolute maximum value at x is equals to minus b by 2a. The maximum value is 4ac minus b square by 4a. For a greater, a is positive minimum value and a is negative maximum value. Okay, now we will understand these concepts with the help of the few examples. The question is, discuss the signs of the following quadratic expressions. Okay, signs of the following quadratic expression when x is real. Okay, now asking us to, what is the sign of these expressions? X square minus 5x plus 4, and another question is going x square minus x plus 3. First we will discuss x square minus 5x plus 4. Okay, x square minus 5x plus 4. Now compare with ax square plus bx plus c and we obtain a is equals to 1. So a is equals to 1 means greater than 0, that means which is positive. Okay, a is positive sign, a is having the positive sign. Now check for this x square minus 5x plus 4. Can we find out the roots for this one? Okay, we can find the roots by seeing itself. We can factorize this as, so we can write this is as x square minus 4x minus x plus 4. So that means now we can factorize this is as x minus 1 into x minus 4. Okay, so now which is having the, if it is a quadratic equation, if we make this is equals to 0, which have this equation will have two values, two roots, x is equals to 1 and x is equals to 4. Now the given quadratic equation having the real and distinct roots, that means we need to discuss about the third point. So what is the third point we are considering? So let's consider one is as alpha and another one is as beta, then alpha less than beta, so that means alpha equals to 1 and beta equals to 4, then alpha 1 is less than 4, the condition is satisfied. Okay, if this condition is satisfied, then we need to have the check for the 2 points. What is the sub points over here? So now the sub points is, if alpha less than x less than beta. So the first condition is, so that means here alpha means 1 less than x less than 4. Okay, in this range the expression ax square plus bx plus c and a have the opposite sign. Okay, in this range the two expressions, what it is, x square minus 5x plus 4 and another is a is nothing but here a is equals to 1, which is positive here, greater than 0, positive. Now in between 1 to 4 the expression and the a have opposite sign. Opposite sign means now x, what is the quotient of x square, positive means obviously the expression is negative. So now in this range x square minus 5x plus 4 is negative. Okay, negative means which is less than 0, and we can write this is as x square minus 5x plus 4 less than 0 in between 1 to 4. If x lies between 1 to 4, that means 1 less than x less than 4, the expression x square minus 5x plus 4 and quotient of x square a have opposite sign, but a is a positive means obviously the expression is negative. And what is the another condition? So x less than alpha, that means x less than 1 or x greater than beta or x greater than 4. In this range the expression ax square plus bx plus c and the quotient of x square have the same sign. These have the same sign means now these are having the same sign means already a is positive, the quotient of x square is positive means now x square minus 5x plus 4 is also positive. Okay, for x less than 1 and x greater than 4, so the expression is positive. We can write it as x square minus 5x plus 4 is greater than 0. Okay, so now what is the sign of the first expression x square minus 5x plus 4? So in between 1 to 4 it is a negative, and for x less than 1 and for x greater than 4 the given expression is positive. So the second question, what is the second question? X square minus x plus 3. Okay, which is the expression he has given. So here what it is, comparing with ax square plus bx plus c. So ax square plus bx plus c, now here a is equals to 1, that means greater than 0, that means positive. Here a is positive, the quotient of x square is positive for the given x square minus 3x plus 3 equals to 0. Okay, so now find out the roots for this one. Okay, it is difficult to find the roots, then check for the discriminant. Okay, to find the nature of the roots, check for the discriminant. So what it is, discriminant is b square minus 4ac. Okay, b is equals to minus 1, c is equals to 3. Okay, now what is b square minus 1 square minus, which is the discriminant minus 1 square minus 4, a is 1, c is 3, then the discriminant equals to 1 minus 12 minus 11. The discriminant is less than 0. Okay, discriminant is less than 0 means what are the roots? Roots are imaginary or complex roots. The roots are complex roots. Okay, now go for the condition 1. What is the statement 1? So if the roots are complex roots, okay, non-real complex numbers, if the roots are complex roots, then ax square plus bx plus c and the coefficient of x square have the same sign. Okay, so that means now the quotient of x square is a is 1 over here, so which is positive, then the expression is also positive. Okay, quotient of x square and the expression have the same sign. The expression is having the quotient of x square as 1, which is positive, then the expression x square minus x plus 3, which is also the same sign, that means greater than 0. So that means the given expression is positive for all real values of x. Okay, positive for all real values of x. Okay, same sign for all real values of x. Okay, so we can say that, so x square minus x plus 3 is greater than 0 for all x belongs to R, the sign of the second expression. Okay, The next question is, for what values of x the following expressions are positive? Okay, he is asking us to find for what values of x these all expressions are, the given expressions are positive means greater than 0. Okay, now first check for the first one what he has given, x square minus 5x plus 6. Okay, we can factorize this is as what is x square minus 3x. So directly I am writing x minus 2 into x minus 3. Okay, we can factorize as x minus 2 into x minus 3. So now we can say that, so the roots of this equation, okay, the roots of this equation having x is equals to 2 and x is equals to 3. That means the roots are real and distinct. So one root has alpha and another root has beta. And for the given expression, so what is the coefficient of x square? A is equals to 1, which is greater than 0. That means the given coefficient of x square is positive, and asking us, so when this expression is x square minus 5x plus 6 is also positive. Now check for the third condition. So if alpha and beta are the roots, okay, the expression a and ax square have the opposite sign in between. Okay, 2 to 3, 2 less than x less than 3, a is positive means x square minus 5x plus 6 is negative, but is asking for positive expression. So in range it is positive for x less than alpha, that means x less than 2, or for x greater than beta, for x greater than 3, the given expression and the coefficient of x square will have the same sign. Okay, will have the same sign, that means which is also be positive for x less than alpha and for x greater than beta. Now the x square minus 5x plus 6 is positive, okay, greater than 0, positive greater than 0. Then what is the solution for the first one? X less than 2 and x greater than 3, which is obtained from the third statement second condition. Third statement second condition, we can say that for x less than 2 and x greater than 3, the given expression is positive. So the next expression is given 3x square plus 4x plus 4 when this is a positive. Okay, for what values of x this given expression is positive? Can we able to find the roots for this one? Okay, directly some it is difficult to find. First of all, we will find the nature of the roots, then we can go for this one. First, what is the nature of the roots? Discriminant. What is b square minus 4ac? Here b is equals to 4, a is 3 and c is equals to 4. By comparing with the standard expression ax square plus bx plus c, and we can say that a is equals to 3, which is greater than 0, that means positive. Okay, a is positive. Okay, right, this coefficient of x square is verified. Then what is the discriminant? 4 square, that means 16 minus 4 into 3 into 4. Okay, that means what is 16 minus what it is 48. So we are getting the discriminant as minus 32 means less than 0. The discriminant is less than 0. So what is the statement we need to consider? The roots are discriminant is less than 0 means roots are imaginary or complex roots. The roots are complex roots. Then what is the first statement? If the roots are complex roots, then the given expression and the coefficient of x square will have the same sign for all values of x, where x belongs to a, for all real values of x, and have the same sign. That means here a is positive means the coefficient of x square is positive. Obviously the given expression is also be a positive. Then the 3x square plus 4x plus 4 is positive, that means greater than 0 for all x belongs to real numbers. This is the solution. Okay, for this one we are using the first statement. Okay, so the next one is 4x minus 5x square plus 2. Okay, 4x minus 5x square plus 2, and we can rearrange this is as minus 5x square plus 4x plus 2. And here what is the coefficient of x square? By comparing the standard equation ax square plus bx plus c, the expression So now a is equals to minus 5, which is less than 0. That means a is negative. Okay, that means a is negative. Okay, right, a is negative. Okay, now then what it is, try to find out the roots. First we'll find the nature of the roots. What is the discriminant equals to b square minus 4ac. So b is equals to 4. 4 means 16 minus 4 into minus 5 into c 2. Okay, c is equals to 2, and we obtain it as 16 plus 20 plus 56. What is 40? Okay, we are obtaining it as 40. Okay, which is equals to 56. Okay, 56 means it which is greater than 0. That means if discriminant is greater than 0, the roots are real and distinct. Okay, real and distinct. Okay, the different roots are obtained. Okay, so that means the third statement has to be considered. Okay, now the third statement has to be considered to find out the to find out the sign of the given expression using the star statement. We need to know the alpha and beta. So now find out the alpha and beta with the help of the x is equals to minus b plus or minus square root of b square minus 4ac. We obtain it as 56 by 2 into a is minus 5. Okay, then we can write this is as what it is. So minus 4 plus or minus, okay, minus 4 plus or minus, and square root 14 4 okay, that means here we will get it as a root 4 as 2 root 14. Okay, 2 root 14 by what it is minus, we can write this as 2 into 5. So minus will be cancelled out, and over here is also the minus is taken out. So if you take the minus again in between plus or minus, minus is cancelled out, and 2 will be taken out. To cancel out the 2 will be taken out, and here will be the 2. Just do the simplification. I am writing over here it is as 2 plus or minus root 14 by 5. Okay, 2 plus or minus root 14 by 5. So that means one root, let I am considering alpha is less than, that means alpha is less than beta, then 2 root 14, 2 minus root 14 by 5 as alpha, and 2 plus root 14 by 5 as beta. Okay, now alpha is less than beta. Now check for the conditions. So he's asking for the expression must be, okay, the expression must be a positive. That means a is negative means, okay, the expression must be a positive means given that a is negative. If a is negative means the expression is positive means opposite sign. When this is opposite sign, the first case, what is the first case? For alpha less than x less than beta, the expression and the coefficient of x square will have the opposite sign. Then for what values of x? 2 minus root 14 by 5 less than x less than 2 plus root 14 by 5. So for this range, the expression 4x minus 5x square plus 2 is positive. Okay, this expression and the quotient of x square opposite sign, the quotient of x square is negative means now in between this range, okay, in between alpha and beta, alpha less than x less than beta, the given expression will be the positive. Okay, by using this concept, check for the fourth question. Okay, so the fourth question solution, you will obtain it is as the roots, you will obtain it is as negatives, and for all values of x you will get it as a positive only. Okay, now we will try to solve these problems. What the question is given, for what values of x the following expressions are, okay, for what values of x the following negative. Okay, for what values the following expressions are negative, that means these all expressions must be less than 0. Let's consider the first question. What is the first question? X square minus 7x plus 10. Okay, by seeing itself the roots can be factorized. Okay, product is 10 and addition is minus 7. That means minus 5 minus 2 minus 7 minus 5 into 2 plus 10. That means the roots are real and distinct. So we can write this is as x square minus 5x minus 2x plus 10. Okay, if you are unable to find out this factorization, just check for the roots. What it is the discriminant? We will obtain the discriminant is greater than 0. After, if the discriminant is greater than 0, we need to find out the roots. Okay, how the roots are finded? X is equals to minus b plus or minus square root of b square minus 4ac by 2a. Now we can write this is as x minus 2 into x minus 5. The factors are x minus 2 and x minus 5. So for this given equation, quadratic equation, x is equals to 2 is one root and x is equals to 5 is another root. So x is equals to 2 is alpha and x is equals to 5 as beta and alpha less than beta. Okay, right. Now what the given ax square plus bx plus c, compare by comparing, here we are getting the coefficient of x square as a is equals to 1, which is greater than 0. Okay, if 1 is greater than 0, we are obtaining it is as a coefficient of x square is positive means, but the expression must be negative. So the expression must be have the opposite sign. That means in the third statement, opposite signs statement is the first one. Okay, in between alpha and beta, alpha less than, that means 2 less than x less than 5. Okay, for 2 less than x less than 5, the expression x square minus 7x plus 10 and the coefficient of x square a have opposite sign, and a is positive means obviously now this must be negative. So now this range 2 less than x less than 5, x square minus 7x plus 10 is less than 0. So that means negative. Okay, when this quadratic equation, the quadratic expression is negative, so for 2 less than x less than 5. Next question is 15 plus 4x minus 3x square. Then write in a standard order what is minus 3x square plus 4x plus 15. Okay, which is the expression. Okay, so now here a is equals to minus 3, that means less than 0, that means negative. Okay, a is negative, so obviously, so a is negative means, and the expression is also be negative, asking us the expression must be negative. So to get this is as a negative, a and b have, so a the coefficient of x square a and the expression must be the same sign. Okay, so to identify this the sign, first we need to find out, can we factorize this? Okay, somewhat difficult to factorize. Then find out the discriminant. So discriminant equals to b square minus 4ac. Okay, discriminant equals to b square minus b square minus 3 square, 9 minus 4 a. Okay, 9 minus 4 a. What is a? A is minus 3. Okay, a is minus 3 plus c means 15. So we are obtaining this is as, so what it is, b square minus 4ac, 9 plus 15 for the 60 into 3 180. Okay, 180 plus 9 180. Okay, check here what it is. Okay, so b is equals to 4 here. Okay, b is equals to 4. Okay, do not confuse, b is equals to 4. This is a is equals to minus 3, b is equals to 4 and c is equals to 15, and b is equals to 4 means 16 which is equals to 186 means which is greater than 0. So that means which is having the roots, okay, are real and distinct. Okay, the roots are real and distinct. Okay, the roots are real and distinct. So now find out the roots. X is equals to minus b, b is equals to 4 plus or minus b square minus 4ac square root of 186. Okay, square root of 186 by 2 into minus 3. Okay, 2 into minus 3. Okay, so if we solve this, we'll obtain this is as, so finally we obtain it as minus 5 by 3 and 3 are the roots. Okay, for this one we obtain this as minus 5 by 3 and just try to simplify this, we obtain this as minus 5 by 3 and 3. So that means minus 5 by 3 is alpha and 3 is beta. So then alpha less than beta. So now if it is alpha less than beta, so the roots are real and distinct. Roots are real and distinct means the third statement. So already it is negative, asking the expression is also negative, only the when the case is both have the same sign. When these have the same sign, for x less than alpha and or x greater than beta. So that means if x less than minus 5 by 3, okay, x less than minus 5 by 3 or x greater than 3. Okay, x greater than 3. The given expression, what it is? 15 plus 4x minus 3x square, and the expression, what is the, and the a quotient of x square will have the same sign. So same sign means it is negative, means the given expression is also negative for x less than minus 5 by 3 and for x greater than 3. So the next question, what? 2x square plus 5x minus 3. So means a is equals to 2. A is equals to 2 means greater than 0. That means which is positive. Okay, a is equals to 2, positive. Then can we find out the factors? It is somewhat difficult to find out the factors. Then find out the discriminant, b square, that means 25 minus 4a. A is 2 into minus 3, that means what it is, 25 plus, so 2 4 2 is 8, 8 3 is 24, that means we are obtaining this is as 49. Discriminant is greater than 0, that means roots are real and distinct. Again, what is the third statement? Okay, again the third statement, first of all find the distinct values. What is, how to find out? X is equals to minus 5 plus or minus square root of b square minus 4ac by 2 into 2 4, and what it is, minus 5 plus or minus 7 by 4. Okay, minus 5 plus or minus 7 by 4, and what will get, minus 5 plus 7 by 4, that means 2 by 4, one is 1 by 2. Okay, so next minus 5, another one is minus 7 by 4, minus 12 by 4, that means another root is minus 3. So we are obtaining the two roots. What it is, x is equals to minus 3 is one root and another root is 1 by 2. Let x is equals to minus 3 as alpha and 1 by 2 as beta. And what is asking, 1 is positive, quotient of x square is positive, but the given expression must be negative, that means check for the opposite sign. So what is the opposite sign? In between alpha and beta, then the given expression and the quotient of x square have the opposite sign. So that means in between minus 3 less than x less than 1 by 2, the given expression, what it is, 2x square plus 5x minus 3 is negative, that means less than 0. Okay, I think you understand how to find out. Okay, how to find out the signs of the, how to find out the signs of the given quadratic expressions using the, what is nature of the roots. Okay, then find out the fourth one, that is giving as an assignment. Okay, the next questions is, what is the next question? He is asking us to find, what it is, find the changes in the sign. Okay, asking us to find the changes in the sign of the expression and find their extreme values, that means the maximum and the minimum values. So he has given that the first question is x square minus 5x plus 6. By seeing itself, we can write this as a factorization as x minus 2 into x minus 3. Now which is having, this expression is having the two roots, one is 2 and another one is 2. Let 2 is equals to alpha and 3 equals to beta, so which is alpha less than beta condition is satisfied. Then the third one, the roots are real and distinct, so in between alpha and beta, okay, in between alpha and beta, the expression and the coefficient of x square have the opposite sign. Here the coefficient of x square, a equals to 1 greater than 0, that means positive. So the in between these roots, the expression is an opposite sign, a and expression have the opposite sign. So 2 less than x less than 3, the given expression x square minus 5x plus 6 and quotient of x square opposite sign means quotient of x square is positive, means this must be less than 0, that means negative. Okay, so now or x less than 2 or x greater than 3. Now in this case both have the same sign, so then the given expression x square minus 6 minus 5x plus 6 is greater than 0, that is positive. So for in between 2 to 3, the given expression is negative, and x less than 2 or x greater than 3, the given expression is positive. And asking us to find the extreme values, whether this is having the maximum value or minimum value. How to find out this? Now here a is equals to 1, which is greater than 0. Now go for the statement 4. If a greater than 0, the given equation will have the minimum value. Okay, will have the minimum value at x is equals to minus b by 2a. So the given expression x square minus 5x plus 6 will have the minimum value. And what is the minimum value? The minimum value equals to 4ac minus b square by 2a. Okay, now substitute over here. What is 4ac minus b square? 4 into a 1. Okay, 4 into 1 into 6. 4 into 1 into 6 minus b square 25 by 2 into 1. And what will get the value as? So 24 minus 25 minus 1 by 4 is the minimum value. And at x is equals to minus b by 2a, minus into minus plus 5 by 2. At x is equals to 5 by 2, the given expression will have the maximum value, the extreme value is, sorry, minimum value, which have the minimum value as minus 1 by 4. I think now you are able to find out the extreme value, that means the minimum value. So check for the coefficient of x square. If it is greater than 0, coefficient of x square is greater than 0, then we obtain which is as a minimum value at x is equals to minus b by 2a, and the minimum value is 4ac minus b square by, sorry, 4a. Okay, 4ac minus b square by, sorry, I am written over here, it is as a wrong, just rectify it. 4ac minus b square by 4a, students. Okay, please rectify. Please rectify 4ac minus b square by 4a, and we are getting, okay, minus 1 by 4 is the correct one. Okay, please rectify this. The minimum value is 4ac minus b square by 4a. So the next question is 15 plus 4x minus 3x square. That means minus 3x square plus 4x plus 15. Okay, which is the expression? For this one, a is equals to minus 3, that is less than 0. If a is less than 0, what are the extreme values? If a is less than 0, which is having the maximum value. Okay, the maximum value is 4ac minus b square by 4a, but we need to check the sign of this given expression. So a is less than 0, then what happened? The discriminant b square 16 minus of 4 into what it is, minus a minus c 15, that means it is total plus 16 plus 15 into 12. Okay, 15 into 12, that means it is totally greater than 0, that means the roots are distinct, real and distinct. Okay, that means real and distinct. Okay, so can we factorize this? 15 into 3 minus 45 plus 4 9 5, that means we can write this as 15 plus 4x minus 3x square as, so 15 plus 9x minus 5x minus 3x square. Then we can factorize this as what it is. If we take 3 as a common, 5 plus 3x, then here minus x as a common, then we write this as 5 plus 3x. Then the roots are what we are obtaining, 3 minus x, the factor size 5 plus 3x. So that means the roots are x is equals to 3 and another root is x is equals to minus 5 by 3. Okay, minus 5 by 3. So that means let's consider minus 5 by 3 as alpha and 3 equals to beta. Then in between minus 5 by 3 less than x less than 3. Okay, the expression. Okay, now go for the third statement. These have the opposite sign in between. Okay, the first one, in between the roots, the expression and have the opposite sign, means the given expression 15 plus 4x minus 3x square. Already the what is coefficient of x square is negative, means which is positive, and whereas x less than minus 5 by 3. Okay, and or for x greater than 3, or for x greater than 3, these have the same sign. That means 15 plus 4x minus 3x square is less than 0, that means negative. Okay, here the a is minus 3 less than 0, then what is the maximum value? Here we'll obtain the maximum value, that is 4ac minus b square by 4a. So now what is 4ac minus b square? 4 into a is minus 3 into b is c is 15 minus b square, which is nothing but 4 square, 16 by 4a, 4 into what it is minus 3, and we obtain this is as 49 by 3. Okay, we obtain this is as 49 by 3, and 49 by 3 is the maximum value or extreme value of the given quadratic expression. I think you understand with this lecture how to find out the sign of the given quadratic expression and how to find out the maximum or minimum value of the given expression. These four statements, these four theorems are very important to find out the statements. And once again I am summarizing as if the roots are complex, for every x belongs to or the expression and the coefficient of x square have the same sign. If the roots are equal also for x at except x is equals to minus b by 2a for all the x values, the equations, the expression and the coefficient of x have the same sign. But if the roots are real and distinct, in between alpha less than x less than beta, the expression and the coefficient of x square have opposite sign, and for x less than alpha, x greater than beta, the expression and the coefficient of x square have the same sign. And for a greater than 0, we obtain the minimum value at x is equals to minus b by 2a, and the minimum value is 4ac minus b square by 4a. For a less than 0, we obtain the maximum value at x is equals to minus b by 2a, and the maximum value is 4ac minus b square by 4a. So I think you understand this concept very well. In the next lecture, we'll come with another concept. Thank you.